Hello everyone, I am G. Vaishali, bearing roll number 447. Today I am going to present a seminar on the subject probability theory and stochastic processing. My topic is about the covariance and correlation and their properties. The first covariance definition is covariance statistical measure that indicates the degree to which two random variables vary together. If both increase or decrease, the covariance is positive. Here, the covariance is a statistical measure that indicates the degree to which two random variables vary together, either they increase or they decrease. The covariance will be positive. If one increases while the other decreases, the covariance is negative. If the if one if one increase while the other decrease, then the covariance is negative. If the change in one variable do not affect the other covariance, then the covariance is zero. Here the covariance formula Cxy it is denoted as Cxy. Covariance equals to expectation of x minus x bar into y minus y bar. Here there is a bar x minus x bar into y minus y bar, where expectation is a expected value. X bar and y bar are mean of x and y. We saw that x minus x bar and y minus y bar, at there x bar and y bar are the mean. The second order joint central movement mu11 equal is Cxy equals to sigma xy equals to mu11 is called covariance. The covariance is also denoted as mu11. Mu11 equals to Cxy for continuous time signal. Cxy equals to integral minus infinity to infinity x minus x bar into y minus y bar into fxy of x comma y dx dy. For a discrete random variables of x and y, Cxy equals to summation n into summation n xn minus x bar and yn minus y bar p of xn comma yk. This is the formula for discrete random variable. Correlation coefficient. For the random variable x and y, the normalized second order central movement is called correlation coefficient. It is denoted by rho and is given by rho equals to mu11 by root of mu20 into mu02 equals to Cxy by root over sigma x square into sigma y square equals to Cxy by sigma x into sigma y equals to sigma xy by sigma x into sigma y. Therefore, rho equals to sigma xy by sigma x into sigma y. We all know that Cxy equals to expectation of x minus x bar into y minus y bar. By this comes here sigma x into sigma y. The correlation coefficient is the normalized second order central movement is called correlation coefficient. Properties of correlation. The range of the correlation coefficient is -1 less than or equals to f less than or equals to 1. The range is from -1 less than or equals to f to less than or equals to 1. If x and y are independent, then f equals to 0. If both two variables are independent, then x of t into y of t. It becomes 0. If the correlation between x and y is perfect, then f equals to plus or minus 1. If x equals to y, then f equals to 1. Here the correlation between x and y is perfect, then the f equals to plus or minus 1. It should be 1 if the correlation is perfect between x and y. If x value equals to y, then the frequency is 1. Properties of the covariance. If x and y are two random variables, then the covariance is cxy equals to rxy minus x bar to y bar. Here, rxy is rxy equals to expectation of x into y. Expectation of x into y. If two random variables x and y are independent, the covariance cxy is 0. If if two random variables are independent, then the covariance is 0. Cxy equals to 0. We should remember this point. If two random variables are independent, then the covariance becomes 0. But the converse is also true. For two random variables x and y, variance of x plus y equals to variance of x plus variance of y plus 2xy. It is in the form of uh, x plus y whole square. Variance of x minus y equals to variance of x plus variance of y minus 2xy. 2cxy. Cxy is the covariance. These are the properties for covariance. If x and y are, there are two more. If x and y are two random variables, then the inequality mod sigma xy less than or equals to sigma x into sigma y is true. If if the two random variables then have inequality, then the mod sigma xy less than or equals to sigma x into sigma y. If x and y are two random variables, then the covariance of x plus a and y plus b covariances of x comma y equals to cxy. The covariances of x plus a and y plus b will become cxy. The x and y terms are becomes cxy. Covariance of x plus a comma y plus b equals to covariance of x comma y equals to cxy. If x and y are two random variables, then the covariance of ax by equals to covariance of ax comma by equals to ab of the both a and b are came out. Covariance of xy equals to ab becomes 1. Becomes 1. Cxy. If x, y, and z are three random variables, then covariance of x plus y comma z equals to covariance of x comma z plus covariance of y comma z. There is a problem on the correlation. Find the coefficient of correlation between x and y for the given table and assume that x and y are equally probable random variables. This is the table inputs x and y. We know that rho equals to sigma xy by sigma x into sigma y. The correlation comes. Sigma xy equals to cxy equals to rxy minus x bar into y bar. We earlier saw that this formula. Sigma x square equals to expectation of x square minus x bar whole square. This is the formula for variance, sigma x square. Sigma y square is also similar, expectation of y square minus y bar whole square. Rxy equals to expectation of x comma x of y. We saw this formula. We discussed x bar equals to 1 plus 2 plus 3 plus 4 by 4. The average of the x inputs. This answer is 2.5. Then y bar equals to, in the same manner, 25 by 4 equals to 6. Rxy equals to expectation of xy equals to 1 into 2 plus 2 into 4. The x and y are multiplied, then I added as an average. The answer is 18.5. Expectation of x square equals to 1 square plus 2 square plus 3 square plus 4 x inputs. It gives 30 by 4, some 7.6 value. Expectation of y square equals to 46. Sigma x square equals to expectation of x square minus x bar whole square. Then sigma expectation of x square answer is 7.5, and the x bar whole square is the x bar is 2.5, then the whole square equals to 1.25. Similarly, sigma y square, the variance of y is 46 minus 6 square, that is 46 minus 36 equals to 10. Sigma xy equals to rxy minus x bar into y bar. 18. The rxy expectation of x into y is 18.5. We saw that. Minus x bar 2.5 and y bar is 6. 18.5 minus 13 equals to 3.5. Then the final formula rho equals to sigma xy by sigma x into sigma y equals to 3.5 by root over 1.25 into root over 10 equals to 0.9899. This is the final answer. Thank you. This is the properties of covariance, correlation, and the definitions of covariance and correlation and a problem. Thank you.